So yesterday, arrows, what do they mean? How do I do this interval notation thing? And it kind of went from there. Hopefully, you played with those 6 problems that we talked about, kind of get an idea of how this works. Because now, when I look at the 2 that we're going to do over here, we're going to do 7 and 11 because something interesting is about to happen that you will run into at some point. So over here on the notes on page 7, not the practice, I go ahead and I distribute. Now it's looking normal so far. It's not going to look normal for long. So I get to this next part, and I'm like, well, I got to get all my x's together, and they're on opposite sides of the inequality. So I got to do an opposite to get them all to the left side. And then weird happens. Oh. All my x's went away. Okay, this is weird. So all I have left is negative 27 is greater than 4. Is that true? No. So since that's false, I'm done here. This is going to be no solution. Okay, that's only true if all of your variables disappear and the statement that's left is false. Maybe you know what's coming on the last one. I don't know. So let's play this back one more time with one more situation. Down on 11. Now here, this minus or this negative is going to go to the parentheses afterward. It has nothing to do with the 6x. So we got negative 3. Negative times negative is positive 5x. Doesn't look too weird yet. I got like terms on the same side of the equals. So again, no opposites, not a minus 5, anything like that. We're just putting those together. Finishing up here on 7. And you probably are seeing it already. I go to get all my x's to the left. I got positive 11x. I'm going to do my minus to each side. And here we go again. All the x's go away. So now I look again. Now I'm like, is negative 4 less than or equal to negative 3? Which number is further to the left? Negative 4, which means that's less than negative 3. It's worse to be $4 in debt to your friend than it is 3. So this one is true. And since that's true, the answer is going to be all reals because every single number would work. There's not really an interval notation per se if all the variables disappear. We just kind of explain what's going on. Now again, is that going to happen a lot? No. But if it does, now you've got something to look back at, bless you, and see how that would work. Okay? We're going to roll that into what we're doing today. So, flipping over here to page 8. We're going to check out what happens when we not only have an inequality in a problem, but we have 2. Or maybe we just have a really big one. And so these are called compound inequalities. And there's 2 types of them. There's what's called the or, and there's what's called the and. So we'll start with or. So here, and I'm going to fix my graph again, open circle is a parenthesis. Closed circle is a bracket. We chatted about that yesterday. And so if I was looking at the graphs of each of these, if I was just looking at my bracket one here at the start, so I'm like, okay, if that was the only thing I had here, I would have x is less than, because my arrow's going to the left, or equal to, because it's a bracket, all these little clues. And I kind of squashed out my -4 when I was making my bracket. We'll get to the interval notation. Or, because there's another part, I look here and I'm like, okay, my parenthesis is opening to the right. Follow the arrow, x is greater than. Not or equal to this time. Yeah. X is greater than 1. So you're like, there can be two pieces to this. There can. And so with an or statement, if we have our two inequalities that are separate, but we go to write it as an interval, this still goes from left to right just like it did yesterday. But this time that means there's going to be two pieces to it. So left, this arrow is going left forever. So for our blue, left forever is starting at -infinity. And as I go to the right until I run into this bracket at -4. Okay, that finishes off the first part of my graph. But there's still another piece over here. So over here I do the same thing again. Where am I starting? I'm starting at 1 with a parenthesis there, just like I see on my graph. And I'm going off forever to the right to +infinity. But to tell the person that's looking at this they know what this is, we put a U in the middle, which stands for union, which means, hey, when you're solving this one, you need both parts of this, not just one like the simple ones that we were doing yesterday. So, anytime you see or, unless it's a very special case, your graphs are going to be going out from each other. It's just another clue for us to think about when we're doing them. So, let me move this up a little bit. We'll do a couple of these. So, I look at this first one, I'm like, all right, doing them separate. All right, so all right, Hardy can't do it anymore. One of the two of you move. I don't care which. Figure out a spot in that left row for now. We'll figure out something permanent later. So we're kind of pretending this one's not here at the start. So I go to 2. I see the arrow's going left, so my arrow's going to be going left. Am I going to be using a parenthesis or a bracket here? Parenthesis. So reminder, if I want it right here so I don't have to flip back from yesterday, if I have greater than or less than, those we use parentheses. If I have or equal to, those use brackets. So parenthesis, we're going to the left. Once I do that, now I'm ready for the second one. I do the same thing. Just solving. That one's done already. I go to 9, I made it. X is greater than. Again, if it's greater than, the arrow's eating X, we're going to go to the right. We've got a parenthesis again. Good, it looks the way it's supposed to. They're not going the same direction. They're not coming together, anything like that. And then I do my interval. Left, any arrow left is negative infinity. To right, till I hit my first symbol. It would be. It would be. Oh dear. Yeah, that's an or equal to. I lost my or equal to. Thank you. Gotta fix that. I always talk to everybody else about the detail stuff, and then I have a detail issue. And then we got another piece over here in blue, though. We're starting at 9, this time actually with a parenthesis. And anytime we arrow to the right, we're going to positive infinity. So with these, it's basically you're doing two separate problems putting together into one. But you're like, uh-oh. There's always got to be a twist to things, right? So let's put a couple of twists in here. Let's twist up a little. Let's go to 4. So you're like, okay, let's see. Here's my first one. Again, we want the A term alone. It's a positive 6. So we're going to minus that out of there. You could even look at it as positive and negative 6 if you didn't want to do the minus part. So we get that out. But then, uh-oh. To get A alone, we've got to divide by negative 2. What happens if we divide both sides by a negative? Yeah, we've got to flip the arrow in the middle. If we don't, we're going to get the wrong half of the graph. Multiply or divide both sides by a negative, we flip. And then we come over here, and we do the same thing. This over a little bit. Now this time, I've got A divided by 2, so I'm going to do the opposite and multiply, but I'm multiplying by positive 2, no flippage here. That would only have been if I did by negative 2, and I'm not. And so I get in here. And again, I have a picture in my brain and on my notes what this should look like, so let's hope it does. A is greater than negative 1. Okay, greater than parenthesis. Or A is less than, arrow's pointing at A, negative 6. Less than goes left. They're going away from each other. That's what I want. And so now again, my interval, there's that arrow going to the left. That's negative infinity. Until I hit my first symbol at negative 6. But there's another piece. So we fire it up again here at the next piece, which starts at negative 1 and heads off to positive infinity. So you're like, okay, can be straightforward. I might have to remember to do a flip thing. Okay. What if, though? What if? Oh, fractions. Okay, let's play. Fractions aren't going to get the best of us. So I'm going to kind of split this like this because we're going to need a little room. So my very first job, I can't minus the 8 first because it's all over this fraction. This is the one time we're going to deal with the fraction first. So here, since we're dividing by negative 3, we're going to multiply both sides by negative 3. Now, when we multiply on the left, We're not distributing it. Its whole job in life is just to cancel out that denominator and just leave us with 8 minus x. We're multiplying both sides by a negative. Oh, star situation. Flip my arrow, and negative times negative is positive. Dang, that's a lot of stuff that's going on here so far already. So I do that. I'm like, okay, I still got to get x by itself. So let's see here. That's a positive 8. So I got a minus 8. Bless you. And then I run into one more twist. Not like there haven't been enough already. To get x by itself, I'm multiplying it by -1. I've got to divide both sides by -1. You're like, wait, we're going to flip it again? Yup. I divided both sides by a negative. That's a star moment. So flip that arrow one last time. And I finally get to my first part. Now again, this is kind of extreme. It's not going to happen a lot, but it can. And so I go one more time over here. I'm going to kind of start writing to this side as we go. Here I am not getting rid of the fraction first, because I can minus the 5 before we go. All right, let's get out of all this crazy. Get ourselves a little bit of room here. So I get that out. If you're comfortable, and we talked about this way back when we were doing equations, if you're comfortable multiplying by the reciprocal, you can do that here. If you're not, I'm like, it's a fraction. I'm dividing by 2. So I'll multiply by 2. Both sides. Get that out of there. Hardy, I don't like how long these take. I get that. I do. There's some things in here that are just going to take some time. And one last time, dividing both sides by a negative. Holy moly, but we've made it. So I get here and I'm like, all right, well, now that I've survived all that, this is crazy. Here's -7. Less than -7, so we're going left. It's or equal to, we got the bracket going. Or x is greater than 4, we're going to the right. With a parenthesis, thank goodness, it still looks the way that it's supposed to. And here comes the interval again. And you're starting to notice a pattern with these ors. They start with -infinity. This one does too. And goes to that first point. Gets in there. And then our union starts up at this second point. And goes off forever to the right. So ors are going to be big and they begin and start with infinity. Lots of little things to keep track of. Now again, most of your problems are going to be more like the first example, but you may run into some stuff like this occasionally, which is why I want you to see it. One last thing. And tomorrow there's not going to be notes. We're just going to kind of rewind and refresh and get you some extra work time, which is always nice to see. So I do want to introduce the and statement, though. You're going to like these. They are shorter. Definitely shorter. But I still got to fix my little dot problem here. Okay. And statement. They're restrictive. They're kind of like if you're one of those types that, I got a few close friends, but I don't need like 10 million people around me, you would be an and statement if you were a mathematic problem. So, here's how this is going to work. We're going to keep this simple. When it's an and statement, I don't see any arrows. You're like, well, that's kind of weird. So here's what we're going to do. I'm going to add 2 little arrows here in the middle for reference. We're not going to need these when we do it later, though. So here, if I have a bracket, which is greater than or equal to -2, and over here at 5, I have a parenthesis, but it would be going to the left. It kind of looks like an or statement. It just says and in the middle. So what's the thing? Here's the cool thing. No arrows going out, right? So there's no infinities with these. This, you just start at the left with your first value, and you end at the right with your second. That's it. Little tiny interval notation, just what's going on in between. And so what tends to start happening to us on these when we're doing it, I can write this in a condensed form, but I don't need to. I can just put the word and in the middle. So for instance, this one, I'll write it once. You might see an answer sometime that looks like this. These actually say the exact same thing, because x is still greater than -2. The arrow's still eating the x. And x is still less than 5. The x is still being pointed at. So again, I don't care which way you write it. When you have answers or you have a quiz, I'll take it either way. I am perfectly content. But if you see one that's all chunked up, we may have to deal with that a little. So here's what we're going to do. You're like, are we going to deal with like what we just dealt with? Yes. Yes. I want you to see a little bit of everything. I'm trying to figure out my time here. Okay, this is going to be good. So here, straightforward one, says and in the middle. I'll get my colors going. If we decide we need more examples tomorrow, we can do them. Still working on getting x alone. Remember, it's this last step that decides if you flip or not. If this last step isn't involving negative to both sides, not just here, but to both sides, we just do that. And we do the same thing over here. Dividing both sides by 8, no negatives involved, no flipping involved. I do want to keep the word in the middle, though, because that's going to be my reminder of what my graph should look like. Because now I look and I'm like, okay, I'm at -6 here on the left. I mean, I can put a little tiny arrow in if I want to, because it's going to the right. And x is less than 4. And if these arrows both keep going, they're just going to crash in the middle. So all I want for an answer is all this stuff that's in between the two endpoints. With the easiest interval notation ever, write down my left point first with its symbol. Write down my right point second with its symbol. I'm done. Straightforward as that. And so, like I was mentioning up above, we're near wrapping up here. I appreciate your patience. What happens if it's one of these big old things and it don't say and in the middle? We're going to do the same thing. We're like, but wait a minute. There's like 2 arrows now. Okay. I still got to solve it like I would any other time. So I got to minus the 4. But I have 3 parts to do it too. The middle and each of the outsides. So here I got 0, 3p, because those cancel out, and 15. P is not quite alone in the middle yet. So we divide everything by 3. And you're like, not sure. So what do I do with this? We go to those 2 numbers. We see they're just going to be parentheses because they're not brackets. And I'm just going to make parentheses like I am around some words or something that I have, and I just color in between the parentheses. left to right. Nothing crazy. Last one. Last note thing you're hearing from me for the week. Unless this is like a future year looking at this and it's not going to be Friday tomorrow. Fraction issue like we had before. Ugh. So I'm multiplying by -2, multiplying by -2, multiplying, oh dear, all three sides by -2. Ooh, though, ooh. Multiplying everything by a negative. Flip the arrows. Flip the arrows. Flip them both. Still working on getting that x by itself. Almost there. So it's just like a regular equation. It's just got 3 pieces instead of 2. And my final step here to get x alone, not add 1, I'm multiplying by -1, so we've got to divide. Oh my gosh, it's a double flipper again. We're going to be ready for everything. When I give you guys regular ones in a lot of these, you're going to be like, well, this was the easiest assignment ever. Oops, did I just forget to flip my arrows? I did. I said it and I didn't do it. What the heck? Okay. 2 is on the left with a bracket. 8 is on the right with a parenthesis. It looks the way it should. The smaller number should always be on the left if we've done this right. And then we just follow the graph that we've got. That was a chunkier lesson than I'm used to dealing with. So, as I said, this will free you from any and all notes tomorrow. So here's the game plan. What we're going to do is on the back of that practice paper we started yesterday. So we were on page 1 yesterday. We were looking at those specific numbers on the front. I will flip there for a sec. I'll put this back up if I need to. So yesterday, we took a peek at 1 through 4, 6, and 7 on page 1. Now today, we're over here on the back. We're looking at day 2. We're just looking at like 9 through 16 this back. Tomorrow, we're going to add a few problems in one other place, but otherwise it's just going to be a work day to work through stuff, check answers, and ask questions.